Okay, so in this video, we're going to solve another nonlinear inequality. So here's the example. So let's go ahead and find the solutions. So first thing you want to do is make sure one side is 0. So move everything to the left. So let's move 1 to the left by subtracting 1. So if you subtract 1 from both sides, we get 1 plus x over 1 minus x minus 1 greater than or equal to 0. Now that one side is 0, you want to combine the left side into a single fraction. So in order for us to do that, we need LCD, the least common denominator. So the least common denominator for the left-hand side, it's going to be 1 minus x. So we would multiply 1 with 1 minus x over 1 minus x. So you can write it as over 1 as a fraction. Once you have that, you have 1 plus x minus 1 minus x all over 1 minus x, a single fraction, greater than or equal to 0. And now we just do some algebraic work, distribute the negative out. We have 1 plus x minus 1 plus x all over 1 minus x greater than or equal to 0. And now finally, by combining like terms on top, we have, so the 1 will cancel out. We have 2x over 1 minus x greater than or equal to 0. Now, this is the important step. Once you get to this step, you want to find the zeros, meaning when is this expression exactly equal to 0? So from top, if we set it equal to 0, we get x equals 0. Great. What about the bottom? If you set it to 0, 1 minus x to 0, we get x is equal to 1. So these are the zeros. Now you take those numbers, you plug them on the real line. Suppose here is 0, here is 1. Now, in order for you to write the intervals, you have to look at two things. Do you want to include those zeros as part of your solution, or can they make the denominator 0? Take a look at this point. Now, this came from above, meaning it's okay to include because this inequality tells us we want it to be greater than or equal to 0, which means the endpoint, we can include them as long as they're from above, not from below. So this can be included. So we will say this interval is negative infinity to 0. Now, what about this one? Well, this is coming from the bottom. So regardless of what this inequality says, we cannot include them because it's from the bottom. So therefore, on around 1, we're always going to put parentheses. So this 0 is not part of our solution intervals, so not included. Therefore, we will say the middle interval will be from 0 to 1, but open at 1 because 1 is coming from the bottom. And then the last interval, 1 to infinity. Again, 1 is not part of our solution because it comes from the denominator. Well, now we have the intervals. Now we just need to select the test value and plug it into the expression. So what are some good test values? Well, from the first interval, we can test, let's say, negative infinity to 0, we'll test negative 1. Actually, I would put it right here, test negative 1. From 0 to 1, we can test 0.5. And then from 1 to infinity, we can test, let's see, we can do 2. 2 is fine. So those are the test value. We're going to plug those into this expression because it's simpler. And we want to see if these test value makes the inequality positive or negative. Okay, so let's plug in negative 1. So for negative 1, we have 2 times negative 1 over 1 minus negative 1. So on top, we get a negative number. On the bottom, we get a positive number. So the result is a negative number. So we can say this interval is negative. So regardless of what test value you pick on that interval, it's always negative. Now let's test 0.5. So for 0.5 or 1/2, we have 2 times 0.5, and then we divide that by 1 minus 0.5. So that would give us positive on top positive on the bottom. So the result will be positive. So this interval, we're positive. And now let's do the last one, 2. So if I do 2 times 2 over 1 minus 2, and on top we get positive, on the bottom we get negative. So positive over negative number gives us negative result. So this interval, we're negative. So now that we finished testing, now it's time to make a selection of which interval is our solution. We want, the inequality says, we want it to be greater than 0. What that means is you want to look at positive solutions. So this implies that we're looking for negative intervals. Sorry, not negative. I meant to say positive intervals because it's greater than 0. Sorry about that. So the intervals that this is positive is only from 0 to 1. So our solution to this inequality, it's going to be including 0 up to 1, not including 1. So that will be our solution to this inequality. All right, so this is it. I hope this makes sense.